Alright, so let's continue with example 15 that involve the one-tail test on the right. Okay, so generally the steps are still the same now, alright? So I will just show you how we actually do it. Okay, so there's in a certain city, it is necessary to pass a driving test in order to be allowed to drive a car. So the probability of passing the driving test at the first attempt is 0.36 on average. Alright, so that means generally, in general, right, for all the while, okay, the rate for passing is 0.36. So that means your P is equals to 0.36. And then there's a driving instructor claims that his pupil passing the first attempt is higher than 0.36. So for this one, this is the keyword to help you in forming the alternative hypothesis. So very obvious, higher. So your alternative hypothesis should be P greater than 0.36. So you get the alternative here. Then a random sample of 8 of his pupils, so the sample is n, this is n, okay, show that 7 passed the first attempt, at the first attempt. So this is your observed value. The 7 will be your observed value that you are using it to calculate the p-value, calculate the probability. Alright, so carry out an appropriate hypothesis test at the significance level at 5%. Alright, so again, we will start with our first step, which is quite straightforward. So first step is the null and alternative hypothesis. P is equal to 0.36. Alternative hypothesis will be P greater than 0.36. Alright, so as usual, I will try to write out a statement about this alternative hypothesis where it is actually the passing time. Oh, sorry, the passing rate, not passing time. So the passing rate is more than 0.36. Okay, so this is my first step completed. All right. Then now, when I proceed to the second step, because I'm testing about the population proportion, so I'm using binomial distribution to solve it. So for my binomial distribution, n is 8, and then the probability is p is 0.36. Okay, then now you want to calculate the probability. So x and then 7. Okay, so you have two options here. Should you use greater equals to 7 or smaller equals to 7? So first method you want to decide is you can look at the alternative hypothesis. So it is greater. Therefore, when you want to calculate the p-value, you follow the sign with the alternative hypothesis, which is greater. So this is the first method that you decide. If you want to use the second method to decide is you try to find out the mean first. So the mean NP is equals to 8 multiplied with 0.36. Alright, so you'll get 2.88. So please imagine that on the number line, the mean is in the center, which is equals to 2.88, and 7 is on the right hand side of 2.88. So when you want to calculate the p-value, you are calculating all the probability at the side, by the side one, at the side. So you should calculate the probability for x greater equals to 7. So this is the second method that you decide the sign. Okay, all right, then now once you know already how to calculate, okay, how you calculate the probability for x greater equals to 7 by using binomial. So your total number is 8, therefore it's very easy lah. You can straight away apply 8C7 0.36 power 7, then 0.64 power 1, okay, then plus 8C8 0.36 power 8, and then 0.64 power 0. Okay, then calculate, just press calculator and get the answer. You will get 0.00429. And this is your p-value. Alright, so I have completed my step 2. Okay, then now I want to continue to my step 3. So for the step 3, I will draw a diagram to help me. Okay, so usually I will draw a bar, a simple bar, okay, that represent the probability, the area and the probability. So I'm having the x value 0 until 8. Alright, so my rejection region will be on the right hand side because it is according to the alternative hypothesis. Okay, it is on the right hand side, one tail test right hand side. So this area, we are talking about area, so this area itself is 0.05, which is actually the significance level given in the question. Okay, then now you want to put in the area for 0.00429. So very obvious, 0.00429 is a very small area compared to 0.05. So you can simply draw a line here. So that means if this is 7, the area that more than 7, okay, the yellow color part here, the highlighted part here is actually 0.00429. Or if you want, you can write out the p-value, okay, is smaller than the significance level, than the alpha, which is equal to 0.05. If you don't want to sketch a diagram, then you can actually try to write out the statement. Then for continue to step number 4. So very obvious now from the graph here, you can see that the 7, okay, and the area is located under the rejection region, right? So what you can do now is you make a decision. So you need to reject the null hypothesis. And since you reject the null hypothesis, okay, so it means that the instructor's claim is supported. So the instructor's claim is supported, which means that it's true lah. All right. For this particular instructor, the passing rate for the first attempt is higher than 0.36. All right. So this is what we have for example 15. Okay. So example 16, I will just leave it for you to try out on your own. I will continue with example 17. All right. So example 17. So this one, I already write out. It is a two-tailed test. Okay, but of course in exam, all these one-tail test, two-tail test, you have to decide on your own. Okay, so in the local election, the Purple Party gained 35% of the vote, and then prior to the Yale's election, the party asked researchers to find out whether support of the party had changed. Okay, so the word change, it can change become more or it can change become less. It is two direction. Therefore, from here, you know that originally P is equal to 0.35. So they want to check whether the support rate has changed or not. So it become not equals to 0.35. Okay, so out of 12 voters, so this is the N, selected at random, 1 said that he would vote for the Purple Party. So the 1 here will be the observed value. Okay, so test at the 10% level whether the support for the Purple Party has changed. Alright, okay, so now again, first step, you write out the null and alternative hypothesis. Okay, so what's the null hypothesis? Your P is equals to 0.35. Okay, then for the alternative hypothesis, it should be P not equals to 0.35. Okay, so what you can do is like the support for the Purple Party has changed. Okay, so first step. Second step, you need to calculate the p-value. Alright, so you should write it out like this. X is binomial distributed. Your n is 12 for this case. Your p is 0.35 for now. Okay, then when you want to calculate the probability, x, your observed value is 1. Okay, so you have two options again. Is it greater equal or smaller equal? Alright, so if you look at the alternative hypothesis here, for this case, two-tail test, alternative hypothesis will not give you any suggestion, right? Because it is not equal, but you don't know whether it is smaller or larger. So for this kind of question, you definitely have to use the mean method. Okay, so calculate the mean for the binomial distribution first. Alright, so you're having 12 multiplied with 0.35, which is 4.2. Okay, so you imagine on the number line, mean is in the center and it is equals to 4.2. So 1 is before the 4.2. So you want to calculate the area here. Alright, so that means the sign for this part will be smaller equals to. Okay. Alright, then after that, to calculate the probability, smaller equals to 1 means that you start from 0 until 1. So 12C 0, 0.35 power 0, 0.65 power 12 plus 12C 1, 0.35 power 1, then 0.65 power 11. Alright, so now what is the probability that you get here when you press calculator? You should get 0.0424. Again, this is your p value. Alright, okay, so this is your second step lah. Then now you continue to third step. Alright, so third step again, you need to sketch a diagram to help you. Alright, so my diagram will look something like this. Okay, so let's say this is x equals to 0 until 12. Alright, so because this is a two-tail test, right? So when you want to shape the rejection region, you have two rejection region both on the left and right. On the both left and right hand side here. And then you have to divide the alpha into two equal parts. So they are asking for 10%, right? So that means when you divide it into two different parts, you're having 0.05 on the right and also 0.05 on the left. So this is your rejection region. Okay, then now you look at the p-value that you calculated just now is 0.0424. So this area is smaller than this 0.05, right? We should draw it on the left because we are calculating the smaller equal sign. Okay, so just make sure that you draw your value here. P-value 0.0424, it will be on the left and it is smaller than 0.05. Therefore, you can draw a line here. This value is a 1. So which means the area smaller than 1 is actually 0.0424. So very obvious, you can see that the 1 here, okay, is actually under the rejection region. Alright, so from here you can try to make a decision and also conclusion. So that means for this case, you reject the null hypothesis. And after that, your conclusion. So your conclusion means that the support rate for the purple party has changed. Okay, so this is what we have it for two-tailed test. So for two-tailed test, in general, the idea and concept are still the same, just that when you want to decide the sign, when you want to calculate the p-value, right, you must use the NP, the mean method, compare it with the mean. So that's the first thing. And then the second thing is when you want to sketch, okay, the graph or the diagram, all right, you have to make sure that you are having two rejection region on the left and right. And after that, you see the area is actually divided the alpha value by 2. So that you add up these two area, it is equals to your alpha. All right, so I think that's a small difference between the two-tailed test and the one-tailed test. All right, okay, so I hope that you understand this. Okay, so I will stop here for this video. Then next video, we will try to consider the large sample size one. Because if you have a look, for all the example that you try under the binomial distribution, all the n here are small sample. That means it is below 31, n below 30. So next video, we'll discuss if the n is more than 30, then how can we run the test?